Hi, cool coders. Today we're going to be looking at how to do loops inside of Python. This allows us to take something and reuse it over and over and over and over again inside of code until a specific condition is met. So let's go right into the content and look at how this is done. Then we'll look at plenty of examples inside of Python. Let's do a brief review of what we talked about when we talked about conditionals inside of Python, where we had a lot of different kind of conditional operators. And we looked at all of these at some level whenever we did a bunch of demos. These will be relevant when we start talking about loops as well, because we're going to be using conditions inside of our loops when we start making these. Also recall that we can take the output of a logical operation and assign that to a variable. So whenever we start talking about doing loops inside of Python, we can use the same kinds of things that we were using with if-then statements and apply that to our loops. So with a loop, we will usually start our program, and our program is running and we have something that's leading up to our loop. And then we come to our loop, and our loop starts with some kind of condition. And that condition is going to be some kind of statement that evaluates to either true or false, just like we saw when we saw an if statement. If it's true, then we enter into our loop. And then inside of our loop, we are going to do something. This is going to be something like a print statement. It could be a logical operator, it could be arithmetic, it could be any number of things that we're doing inside of that loop. It's just some code that's in that code block that's delineated by the loop structure that we have in our code. But unlike an if statement, it's not going to exit and continue on. What it's going to do, instead of exiting and continue on, it's going to go reevaluate the condition that caused it to enter into the loop. So this condition has to be met again for it to recycle the loop. So it might run once, it might run 10 times, it might not run at all. But in any case, when it reevaluates it to true, it'll run the cycle again and then again and again, as long as that condition remains true. The only case where it will leave the loop is if that condition is reevaluated and it goes to false. So what that means is that some point in the loop, in that code, you're going to have to change the condition so that it will actually evaluate to false. And we'll look at some examples of how this is done in just a second. But at some point, you have to exit the loop, or you're going to end up with what we call an infinite loop, which in code can sometimes not be a good thing. So let's go and look at some of the code examples, and then we'll go into Tony and we'll look at how to write these things and how you can use them in your code. When we talk about loops in Python, there are two basic loops that we can talk about, and the first one is a while loop, which we see here on the screen, and the second one is a for loop, which we'll mention in just a moment. Now, a while loop looks a lot like an if statement that we've seen already, and in the if statement, we had a condition that we're going to evaluate as true or false, and if it was true, it would enter into the code block defined by that if statement, and the same is true here for the while loop. So we need something to evaluate. So we're typically going to have something that's going to seed a condition, such as a variable. And in this case, I have a variable that's an integer and its value is set to 0. And then I'm going to come down into my while loop block here, and I'm going to evaluate that particular variable. And I'm going to use a logical operator. And in this case, we're using the less than operator. So while less than 10 is true, and that means I'm going to enter into the code block, which is denoted by a colon, like we've seen already, and then some indentation that we have used to denote code blocks in our if statements. And then what that's going to do is it's going to execute some code right here. It's going to print something to the screen, and then it's going to do something else to the value of x. So basically what it's going to do here is it's going to take the value of x, which is currently 0, x is 0, and it's going to add 1 to it, and then that's going to equal 1. And so then it gets to the end of the code block, and it's going to go back up here and reevaluate the value of x that has been reassigned to a new value. In this case, it's going to be 1. So x is still less than 10. So it's going to, again, go through this process, print the value of x, and then iterate on x again. So x is now 1, it's going to add a new value to it, and it's going to be 2, and then 3, and then 4, all the way up to the time that I get to where the value of x is 10, because x as a value of 10 is not less than 10, it's 10, and so they're equal, it's not going to go back into my code block. Instead, it's going to come down here and print all done, because that evaluates to false. So that's the kind of basic logic that we'll have with a while loop. So let's go over to Python and Tony and do some examples of this so you could see it in action. Okay, I'm here inside of Tony now, and I want to create a loop basically like I had on the previous screen. So I'm going to start off with a variable x equals 0, and I'm assigning a value to x, and that's an integer, as we know. And then I'm going to create my first while loop here. I'm going to say while x less than 3, and then I'm going to do my colon right there. And then Tony's going to indent for me because it detects that I have a code block. I'm going to do a print command here, and I'm going to do some parentheses x, and I'm going to put a colon and then put a space, and then I'm going to do a comma, and then do the value of x right there. And then I'm going to add to x. I'm going to do x equals x plus 1. Now, what I have here is an iteration on x. So it's going to take the current value of x right here and then add 1 to it, then assign it back to x. And then I'm going to add another command here called print all done. So this is basically what we saw just on the last slide. So let's run this in debug mode and let's see exactly what's going on inside of this code. I've got a breakpoint here on the first line. So if I run this, it's just going to break right there on the first line. And so I want you to watch the variables and the shell while we step through this code. So I'm going to step into this and notice that the value of x is currently 0, and it's going to evaluate that condition right there. Now that condition is going to evaluate to true, and it's going to enter into my code block. So we should expect this to print that new value of x, and that is 0. So after that prints, we're coming down here to x equals x plus 1. So what's going to happen now is it's going to take the current value of x, which is 0, add 1 to it, and then assign that back to x. And so now x is now equal to 1. And now it went back to my condition in my loop to reevaluate the condition. X is still less than 3, so it's going to come back into my loop. And then again, it's going to print x, and then it's going to come down here and then add 1 to x. So x was 1, it added 1 to it, now it's 2. It's going to reevaluate that condition because x is 2, it's still true. It's going to come back down into our loop, print the value of x, which is now 2 down here in the shell. And now it's going to add 1 more to x, which is currently 2. So 2 plus 1 is 3. It's going to come back up here to our condition. It's going to reevaluate it again, but this time it's going to evaluate to false because x is not less than 3. X is equal to 3. And so it's going to leave our loop, come down here, and then print all done. So our program is now finished. So what we have here is an example of a very basic while loop where we can see what exactly is going on inside the code. Now we could change this up and get some different parameters if we so choose, but it's pretty straightforward about what's going on inside of this. In our slide, we saw 1 through 9 or 0 through 9, and this one we're seeing 0, 1, and 2, but we're not getting to 3. So if I was to change this to a different condition right here, less than or equal to 3, and I run this, it's going to print 0, 1, 2, 3, because that it still evaluates to true when x is 3, but whenever it becomes 4, that's no longer the case. What we want to avoid, though, is creating conditions that result in infinite loops. So if I had a condition where I had some hard-coded value, 1 equals 1, like that will always evaluate to true. No matter what I do, I will never leave that loop. So if I run this, it's just going to print numbers, numbers, and numbers until I stop it. That's an infinite loop. I cannot exit that loop because there's no exit condition. So I'm just going to hit stop right there to stop execution of it. So that is an example of a infinite loop right there. And that's kind of what we want to avoid in our programming. Sometimes you're going to create conditions accidentally where you're going to end up with an infinite loop in programming, and your program is not going to be responsive. You're going to be like, what's going on? And you'll need to be able to stop the program from running. Inevitably, you will create infinite loops in your code, but just understand that, oh, that's what I'm seeing, and then work to figure out why you're getting an infinite loop, and then fix your condition so that you can actually exit your code. But just because something will compile, like I said, it doesn't mean that it is actually good code. That means there's a bug in there, and that's resulting in an infinite loop. So here on the screen, we have the second kind of loop that we are going to talk about today, and that is a for loop. Now, a for loop in Python is strictly used for iterating over things. Now, on the previous example that we looked at, we were iterating using a variable called x, and the code that we have on the screen right now, it's functionally identical, more or less, to what we were doing on the previous example that we were looking at. A for loop is designed for this purpose. While loops can do some other things, and I'll show you an example of that in just a moment. But a for loop is principally the kind of loop that you're going to want to use if you're going to be counting between a certain number and another number. And so you have a seed condition, you will have a condition, and then you will have some kind of iterator that you want to apply to that. And so what Python does is presents this in this thing called a range, or a function called a range. So let's take a look at what this looks like right here, if I can get my pen. Now, a range defines it by using this range keyword right here, which is a function, as we've seen before, that sets up a series of numbers. And the initial condition right here is the value of the first thing in that range. So this is essentially like setting x to 0 when we go into our while loop. So we're going to start off with 0. Our condition then is right here, and this second parameter that we have here, in this case 9, and this is where we're going to loop to. And this is a maximum value of 9 for this particular range. So we're basically going to say everything from 0 to 9. And then we have in the third parameter what is called a step, and this is the value in which we want to iterate by. So how much do I want to add between each different iteration to the value of x so that I can create a loop? So if I set it to 1, it's going to iterate 0, 1, 2, 3, 4, 5, and so on. If I set that to 2, it's going to be 0, 2, 4, 6, and so on. If I set that to 3, it's going to be 0, 3, 6, and so on. If I wanted to go backwards, I would simply start with a new seed condition, which would be something like 10, and then my minimum value would be my second parameter, which would be something like 0, and then I would use my step to be -1, and that would count down in that case. So setting up a range is how we can iterate over a series of numbers inside of a for loop. Now, a for loop is used for other kinds of iterations too, which we'll talk about when we talk about lists and tuples in a few weeks on other lessons. But in any case, understand that a range is basically setting up a series of numbers, and then we're going to take the variable x and then go through each number in that series and do something with that number. So what we're going to do in this case is we're going to print something, and we have a code block just like we had before where we have our indentation, and we're going to take the value of x and print it. And then once it gets to the maximum value, it's going to exit the loop and then print this right here. So we've seen this before where we have the similar construct, but in this case, it's a little bit more obfuscated inside of what we're doing with this for loop construction, rather than being more explicitly defined as we saw when we were dealing with a while loop. Okay, I'm here inside of Tony, and I want to basically do what I did on this page. I'm going to do a while loop that looks like this, except I'm going to do a for loop. So let's see what this does just to get a reminder. It's going to print 0, 1, 2, and then all done. So let's come over here and set our for loop up. So I'm going to start off with 4, and then I'm going to put for my variable name and then in. And then I'm going to set up a range. Now, for x in range, some initial value, so 0, the max value, it's never actually going to get to this value. So I'm going to set it to 3. So this should be 0, 1, and 2. So that's the max value less 1, so it's going to be 0, 1, and 2, just like we saw whenever using the less than symbol in our while loop. So let's go ahead and then do our step, which is going to be, in this case, 1. This is optional if your step is 1, but I'm just going to be explicit right here. And then I'm going to do a print command, and I'm going to say print, just like we had down there, x colon space, and then I'm going to say the variable x, and let's close that up with a parenthesis, and I can't forget my colon, that's important. And then I'm going to say print, and then I'm going to print all done. Now, this should print 0, 1, and 2, and then it's going to evaluate against 3, and this is okay, I've met my condition, therefore I'm going to leave. So basically anything less than 3 for this particular setup right here. So let's go ahead and run this, and let's see what happens. And I ran it, I got exactly what I saw down there, and it looks just like I saw my while loop right there. So let's run the debugger and see what this looks like. So it's going to break on this breakpoint that I have here, and let's watch the variables over here. So I'm going to step into this. X started off with 0 because that's the first one in my range, and so it's going to print, I would expect it to print X down there of 0. It goes back up here to line 2, and then it's going to reevaluate the condition again. It's kind of obfuscating that a little bit under the hood, and we're going to say, okay, it's still within that range of the between 0 and 3, and it's going to come down here and print that new value. So it added 1 because of my step being 1. And so X is now 1. It's going to come back up here, evaluate that again, that condition, and then it's going to come down here and print the value of X again. Now this time it's 2 because it stepped up the value of the variable. And so now I'm at the end of my range. And so it's going to do the end of my range, and that's going to detect that I'm at the end of my range. Therefore, it's going to leave my loop, and it's going to go down to all done and then print that value. And so you can see where it started off, just like we did on the other one, it started off with the initial value right here of 0, and then it did an iteration over that from 0, 1, and then 2, and then it got to the end of the range and said, okay, I'm done, and it exited the loop here. So let's look at some other examples with some other steppings that you can do with this. And this is something that you will have to get the hang of doing. So if I wanted to say, let's do some 0 to 10 and with a step of 2, and let's see what this one looks like. And let's say all done. I'm going to change the annotation here a little bit. The output, all done step 1, all done stepping of 2, just so that we can have a little bit of clarity in the output down here. And so I finished up with all done step 1, and then I'm coming down here to 0, 2, 4, 6, 8, gets to 10, and then it goes out of the loop and into this last line of code down here. Likewise, we can go backwards. So let's come down here and let's change our range from 10 to 0 and do a step of -2. So this will count backwards. So it should start off as 10 and then exit before it gets to 2, before it gets to 0. So it exits on 2. And that's what we have. 10, 8, 6, 4, 2, and then all done with step 2 down here. I'm going to put -2 rather for that. And then let's do one more example. In this case, I'm going to do another stepping of, say, -1 if we just want to count by ones in this case. So -1. So this will go 10, 9, 8, 7, 6, 5, 4, 3, 2, and then 1, and then exit before it gets to 0. So let's do that. And oh, I need to change that to step 1. So let's change that like that and run it one more time. And we can see where it's counting down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then all done step -1. So here are 4 different examples of for loops where we're going from a initial value and then exiting once I get to this value right here. So that's how a for loop works. We're going to be looking at other examples of for loops when we look at lists and tuples, and for loops can be used to what we call iterate over those as well. But this is one way to use them for counting numbers and whether that count is positive or negative or 1, whether that's 2, 10, 15, whatever it might be. But this is a good way to use a for loop, and it's very concise code compared to doing it with a while loop. So this is actually more preferable. I want to go revisit the while loop again because in our first example, we saw the while loop where it was doing an iteration over a series of numbers. We were counting from 0 to 9 and we were printing the results on the screen. In that code, we had a variable that we explicitly set. We had a condition that we tested. Then inside of our while loop, we would increment the value of the variable we were testing and then repeat that until we got to the exit condition, which is when it was less than 10 in that case. So the variable got to be 10 and then it would exit the loop. Then we took that same code essentially and reproduced it in the for loop. And I did that on purpose because I wanted you to see the code explicitly defined inside of the while loop and then show you the for loop, which took basically what the while loop was doing and made it much more concise. It did in basically one line of code with the while loop took 3 lines of code to do. And so I wanted to revisit the while loop again to show you that you can use it for things other than iterating over a series of numbers. So what I have here on the screen is the basic same kind of structure that we had before, but in this case I have an X variable and I've set it to a string. And down here in my while loop, my condition is testing X against some hard-coded value for P. So while X is not equal to P, in this case, X is empty. So X is not equal to P. So that's true. There's my colon in my code block indentation. And I'm going to say X is then going to be reassigned to something that I input in from the keyboard. So I'm asking the user to do some user input. So that could be a letter. I'm asking for a letter, but in reality, it could be any string. It could be an emoji. It could be A, B, C. It could be some kind of character from another language. It doesn't really matter. And it's going to assign that value to X. Now, once I have that value for X assigned, I am going to then go back and retest it against my condition right here. So if I enter in A is not equal to P, and then it's going to come back into my loop and prompt me once again to enter some value. And it's going to continue to do that until I enter in a capital P, and then which that case, it would then exit the loop and then come down here and print all done. So that is a condition and an example where I'm not using some kind of iteration over a series of numbers. Rather, I am expecting some input from the user, and I want that user to enter in a specific value so that I can reach an exit condition and then continue on with my program. So let's go over to Tony and type up this example or something like it so you can see it in action. Okay, let's do that example that we just saw on the previous slide. So let's do some string variable. I'm going to assign that to X. So that's basically an empty string right there. And I'm going to do a while loop, and I'm going to set up my condition here for where X is not equal to some value. So in this case, I'm looking for X not equal to A for this to be true. So if I enter in B, that would mean that B is not equal to A, which is a true statement. And then I'm going to come down here into my while loop. So in this case, I'm not going to do a print. I'm going to do input, and I'm going to say enter in some value for X. And then basically want the user to put in some value for X. And I'm going to assign that to the X variable. And as long as they enter in something other than A, it will continue to loop. And then I'm going to say print you entered A, and then it will end the program. So let's run this, and you can pretty much guess what's going to happen. If I run this, I'm just going to, I forgot to put something into my quote here. I have a syntax here. And let's run that. And there we go, that's better. And I'm going to enter in some values here, and I can enter in pretty much anything for the value X, and it's just going to continue to ask me to enter in some value for X until I enter in a capital A. And once I do that, it's going to exit the loop, because if I say A is not equal to A, that's going to evaluate to false, and then it's going to exit the loop, just like we would expect. And this is fairly simple logic, but I can use more complex logic inside of my while loops. And that can be done with multiple variables, for instance. So if I said, in this case, I said X is equal to A. Let's say if I did a Y variable and I said B. And so I said, while X is equal to A, or Y is equal to B. So as long as X is equal to A, or Y is equal to B, as long as one of those is true, I'm going to continue to loop. So I'm going to say enter in some value for X. And right here, I'm going to do another variable where I'm going to say Y. I'm going to change this right here to Y. So this is going to now prompt me for some data for the value of Y. And I'm going to be contesting this condition for truth. So basically, either X has to be equal to A or Y has to be equal to B for this to continue to loop. And then if one of these, if this one is not equal to A and this one is not equal to B, then it would exit. So let's go ahead and run this and see what happens. You entered in some data. Let's just put that from exit condition, exit command there. So let's run this, and we're going to hit that first loop first. And you entered A. Okay. Now it's entered into this one right here. So let's go ahead and enter in some value for X. Let's go ahead and enter in an A for that. And let's enter in something else for Y. And because Y was equal to ASDF, whatever this is, this evaluated to false, but this evaluated to true. And because it's an or, so long as one of them are true, it's the whole thing is true. So it's going to enter into the while loop again. So if I enter in something for A this time, and then I enter in B, it's going to come back in my loop again, because this one is some value that evaluates to false, but this one evaluates to true, so the whole thing evaluates to true, and then it comes back into my loop. So on this iteration, if I enter in some value that's junk for both of them, it's going to exit, and because neither A nor B were the values that were entered. So it needed to be something that would cause this to exit. In that case, I just entered in ADF and ASDF, and both of these evaluate to false. Therefore, the whole thing evaluates to false, and then it exits the program. So you can see here, I have a condition that is much more complex logic than a simple singular type evaluation like we had up here, because this is where while loops will come in handy, is when you need to do these kinds of logical operations against your code. So let's go look at one more concept, and then we'll go to our challenge. The last concept I want to introduce is the idea of random numbers. Now, this really has nothing to do with looping. The reason I want to introduce it is because we're going to be using it a lot over the next several lessons. And like I said, whenever we launched this, I wanted to give it a little bit of emphasis on gaming. And one of the things that many games have are random events. So you think about a game, you have the throw of a dice. So you get some number that is represented by the throw of a dice, or you might draw a random card, or you might do a spinner or something like that. It produces some random event in the game that affects the outcome. And similarly, inside of a computer game, you might have random events as well. And that's usually determined by the generation of some kind of random number using code. So that's what I wanted to show you today, so we can use that in our challenge that we have coming up, as well as some in the future. So it really doesn't have anything to do with loops. It's just a cool concept whenever you're writing games. So let's look at what random numbers look like. So here on the screen, I have some sample code here, and I have this import keyword. Now, import in Python is the ability to extend Python beyond its basic functionality that comes out of the box. So this is basically going to import a class or some kind of library that has the ability to create random numbers. That's not a part of the core features of Python. So to get access to that, I need to import it. And this is something we'll cover more in depth later. But for now, just know that by using import, I'm extending the core functionality by adding random to that. And so to generate a random number, now that I have it imported, I can then call a function on random. So here notice I'm typing in random and then I'm using this dot operator right here. That's so to get access to what is on random, I need to say random dot and then whatever function I want to call to get access to that is provided by random. And so in this case, I want to get a random integer. So I want to get a random integer, and the two parameters I'm going to put into random integer are essentially the min and the max of what is going to be returned by this particular function. So it could return 0, it could return 10, or anything in between those that is an integer. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 would be the possible values that could be returned by this. And so once I get that random integer, it's going to then take that and assign it to X, and then I'm simply just going to print that to the screen using print. So let's go over to Tony and run this program, and then let's extend it a little bit, just have a little fun with it, and then we'll go to our challenge. So I'm here in Tony, and I want to create a program basically like the one we had before. So let's import random, import, if I could spell right, random. And with this, I have random available to me now. I'm going to do X equals random, not tandem, random. And I'm going to say rand int, and I'm going to set a min value, max value, could be any max value, any min value, and then I'm going to say print X. Now this should print out some value between 0 and 10. So if I run this, let's see what I get. I got 10. Let's run it again. I should get something. When I get 10, I got something else this time. 5. Let's run it again. I got 9. So you can see that I'm just getting some random numbers based on random number generation right here. So let's make this a little bit more interesting, and let's take these 2 lines of code and let's generate, say, 10 random numbers, for instance, or maybe 100 different random numbers. I don't know. Let's do a for loop. So I'm going to do for, let's say, in my range, and I want to go 0 to 100, and then I'm going to step 1 colon, that's my block, and then I'm going to say X equals random number 1 through 10, and then I'm just going to print that out. So this is going to generate me 100 random numbers between 0 and 10. And let's run that. We should just get a bunch of junk on the screen. I need to do like that. I need a variable for that. Fix that up, and there we go. I got a bunch of random numbers down here that it's generating. That's, running over this 100 times to generate me 100 different random numbers between 0 and 10. So that's one way that you can use random. So let's go over to the challenge, and I want you to think about everything that we've talked about up to now, including random numbers, to think about how you're going to solve this challenge. I don't think this one's going to be the easiest one in the world for most folks, but it's going to require you to think about while loops, conditions, random numbers, and so on. And then I'll show you my example, and then we'll go from there. For the challenge, I want you to create a number guessing game. So this is a fairly easy game to create. Think about a number guessing game. I'm thinking in my head of a number between 1 and 100. Okay. And then the player goes about guessing numbers until they get it right. That's basically what we're asking for. So basically, you're going to generate a random number. So pick a number. And then you're going to ask the user to input that number until they get it right. And when they get it right, they win the game. Now, as a bonus, I want you to incorporate a maximum number of tries. So this would be, some max number of tries. Say you want to give them 10 attempts or maybe 5 attempts to get it right. And if they don't get it right within 5 attempts, they lose the game. Or if you want to get real fancy, you could ask the user to enter a number for the maximum and then enter the number of possible tries. And then you could then get them to try to guess the number the computer randomized and then do it within a certain number of tries. So let's go look at my example. Mine's going to be the maximum example that you could possibly do, but I want you to basically generate a random number and then get the user to input a number until they guess it right. So that's fairly straightforward. That's the minimum challenge, but you can of course extend on that using some of the things I'm going to show you in my example that we'll look at here in just a second. So I have my solution pulled up here inside of Tony. I'm going to run it. And this is the first 3 lines. So you can see that I am using random numbers in this because I'm importing random and I'm printing off, the name of the game, etc. But let's run this to see what happens. So I'm going to go ahead and run this. So basically what I'm going to ask the user for is what's the maximum you would like to try for? So I'm going to say number between say 1 and 100. I don't know. So 100 is my maximum here. And how many tries would you like to have? So I'm going to do 10 tries. Now you don't have to prompt the user for these values. You can just hard code them in if you want, but just to make it more fun, I decided to allow the user to enter these parameters for the game. And so guess a number. And so I'm going to guess 50. And because 50 is too high, I'm going to say too high. Now, you don't have to do that. You could just say try again or something like that until they get it right. And then I'm going to say too low for 10. Let's say 25, somewhere in the middle. Okay, 15. 15 was the number. You got it. And so you can see there I'm guessing numbers until I get it right. And that is what I'm basically looking for. Now, of course, you don't have to make it nearly as fancy where you're saying too high or too low. You can if you want. That would use some if statements if you want to incorporate those. But basically you want to prompt the user to guess a number until they get it right. And that can be a very simple program, or it can be something much more fancy like I have here. And then once you get that, submit it to me for a challenge, and then I will have a $10 Amazon gift card for all those who complete the challenge and then submit it to me. So looking forward to seeing you on future lessons of Cool Enough to Code. If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcenouments related to Cool Enough to Code. You can also help us out by becoming a patron on our page by going to our Patreon page at patreon.com/coolenoughToCode and then clicking on Become a Patron. And there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here. And you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.